Melang, Sanbonan, Aufshin, welcome. And my name is Altin Tower, and today we'll be doing trigonometric identities for both grade 11s and 12s. Okay, so in trig identities, there are some identities that you should know. Eyokuqala, the first one is that tan theta is equals to sine theta over cos theta. And then the second one, it's known as the square identity. And then we say when you are my sine squared theta and I sum them with my cos squared theta, together they are one. And then now from this identity, you can change around to make either one of them to be subject of the formula. For example, if I'd take cos squared theta to the right, I would have sine squared theta is equals to 1. Because it's positive, when it moves to the left, it becomes what? A negative cos squared theta. So this we can say it's 2.1. And then the second identity, you can create it from the square identity by moving sine squared theta to the right hand side. So you'd remain with cos squared theta is equals to 1 minus sine squared theta. So guys, it is crucial when you are dealing with identities to be able to factorize and know your fraction laws. Like, many people send me messages saying they're struggling with this topic. So the aim is to understand the factorizing part and the fractions. Okay, so the first one I'm gonna start with, it's the common factor. So the first thing, every time when you're dealing with identities, you should be able to see a common factor. Let's say, for example, now you are given 2 sine theta times cos theta minus cos theta. So you are given something like this and you are trying to solve or simplify there. So what you do is you check for a common factor. So what is a common factor? A common factor is a term that is common for 2 or more terms. If you don't know what is a common factor, you can check out our algebra videos on how to find a common factor. Okay, so you notice that on this term you have cos theta, and on your other term you also have cos theta. What does this tell us? It tells us that cos theta is common for both terms. So into ozoyenza lana ukuthi uzobhala ukuthi cos theta open bracket, and then to get 2 sin theta, so masusa lo cos theta salelwa yini u2 sin theta. Don't remember a sign, so it's a negative, and to get cos theta again we should multiply by 1, and now you have factorized. Now let's check another one. Let's say now you're given something like cos squared theta minus cos theta. Okay, so you're given cos squared theta minus cos theta. So they say simplify or factorize. So you check, okay, cos squared theta, you know, last videos I said this means that you have cos theta times cos theta, because cos theta times cos theta is cos squared theta, and then minus cos theta. So what do you see? You notice that cos theta is common for the first and common on the second term. So you can take out cos theta as a common factor, and therefore to get cos theta times cos theta, what do you have here? Another cos theta. Don't forget the sign. Because you have cos theta, you put a 1, and now it's factorized. So let's do more of these questions. let's say now I'm given 3 sine theta minus sine squared theta. So abaningi mase kanjena bayakhomplela bathi hayi senzima ndoda. Okay, ungathuki phela. Into eqala ufanele ukuyicheck ukuthi yini oyibonayo efanayo between lama terms lawo. So uzocala uthi 3 sin theta minus, so siyazi ukuthi u-sin squared theta usho ukuthini? Isho ukuthi it's sin theta times sin theta kanjena. Bese soyabheka ukuthi okuphi okufanayo kulama terms lawo momabili. So uyabona ukuthi sino sin theta lana nangapha sinomunye sin theta. Okay, so keep u-sin theta as a common factor, then uyabheka ke kusale bani u3, right? And then minus ungayikhohlwa le sin, bese kusalani usin theta oyedwa kanjena. So ma we distribute back izokupha whatever it's on top, and then it will be correctly factorized. And then now let's check one more example. Let's say now you're given 5 tan theta minus 2 tan squared theta kanjena. So sweswi letala kusolva kumbe factorizer a trigonometric identity lengetani. So xo sungula xi langutaka iswaku i xi nga common ka ti terms letimbirhi. So uta sungula tsala 5 tan theta minus 2 tan squared theta leyiwa u hlaya swaku una ti tan timbirhi leti multiply nako. Se loko so hetile ku expanda from tan squared theta to tan theta times tan theta, uta checka leswaku i xi nga common ka ti terms letimbirhi la. So kuma leswaku kuna tan theta ka term yo sungula na ka term ya vumbirhi. So uta tsala leswaku tan theta iswaku yona common factor yina. So u veka round bracket ya wena, u cheka swa ku salelwe yi, wabona uselelwe yi 5. So ubuya utsala sign kunga minus, then wabona swa ku iselelwe yi 2 na tan theta. So utatsa swa ku 2 tan theta. So upfala bracket ta wena u factorizing. So every time u cheka swa ku kuna common factor na loko endla yini the identities. Okay, now it's not always going to be common factor. Sometimes you can be given a trigonometric trinomial. So these ones tend to give learners a challenge, but I'll explain it. So let's say now you're given sine squared theta plus 5 sine theta plus 6. This is called a trigonometric trinomial. As you can see, it's similar to a quadratic, which is our ax squared plus bx plus c. So you notice that sine has been raised to the power 2, and then there is one x term, which is our b. In this case, it will be 5, and our constant would be 6, the value without the x term there. So there are two methods. You can change both the ratios to a certain variable. Let's say now you can say let k be sine theta, right? So you can say let k be sine theta. So you know that since it's sine squared theta, it's going to be k squared and then plus 5. So where there's sine, you'll put another k and then plus 6. So you notice that now you have a trinomial which you are familiar with. Since now the value of a is positive 1, you are going to check the factors of the constant term. So the factors of 6 are going to be 1, 6, 2, and 3. So you are going to check the factors of 6. When you add, they should give you the value of b, which is a positive 5. And when you multiply them, they should give you positive 6. So you notice that if I can take 2 and 3, why? Because 2 plus 3 is 5, and 2 times 3 is a 6. Therefore, you'd say k open bracket, k, and then we'd have plus 2 plus 3. But now remember, you said that k is sine, right? Therefore you can rewrite it and say sine theta plus 2 and then sine theta plus 3. And now you have factorized this part, which is our trigonometric trinomial. Okay, let's check another one. Let's say now you're given cos squared theta minus 9 sine theta plus 20, right? So you can always introduce a variable like k, p, x. Doesn't have to be k, guys. So what you notice is that this is a trigonometric trinomial, and you check, okay, the value of a, it's a positive 1, so I can check the factors of the constant term, which would be 20 in this case. So 20, the factors of 20, it's 1, 20, 2, and 10, 4 and 5. I think 6 does go 6. Nah, it will never be 6, guys. Okay, so now we are looking for the factors of 20. When we add them, we should get a negative 9 because this is the value of p, right? And then when you multiply them, you should get a positive 20 there. Okay, 2 minus 10 doesn't give a 9. There is no 9 here. But when I check 4 and 5 there, 4 and 5 does give me a 9. But what kind of a 9 am I looking for? A negative 9. Therefore, both my terms should be negative. Why? Because minus 4 minus 5 is minus 9. Then you check, when I multiply them, does it give me positive 20? Let's check. Negative 4 times negative 5, it's a positive 20. It does. Therefore, these are your correct factors. Therefore, you'd just say cos theta minus 4, and then oh, I made a mistake, guys. It's supposed to be cos here. Sorry for that. It's supposed to be cos here. So you'd have another cos theta minus 5. So this is how it would look like. I'll do that example where you have cos and sine, but not on this video. I'll do it on a separate video. Apologies for that one. Let's change my paper. It's full.
A few moments later.
So now let's get into our third example. So let's say we have tan squared theta minus 7 tan theta plus 12. So let's say we have something like this. So into qala ukuyenza lana uyabheka ukuthi okay ngine power 2 ngine term a1 efanayo. Kusho ukuthini lokho? This is a trigonometric trinomial. Bese uyachecka lana ukuthi okay ivalue ka a ubani? U1. So if ivalue ka a u1, uyazi ukuthi okay sichecka ama factors we constant term. So the factors of 12, it's 1, 12, and then 2 and 6, then 3 and 4. So we are checka lapho ukuthi okay ama factors ka 12 mangwa add azongipha minus 7 ane, bese mangwa multiply angiphe positive 12. Uyabona ukuthi okay u3 no4 banayo 7. Why? Because ngiyazi ukuthi minus 3 minus 4, it's minus 7. And minus 3 times minus 4 izongipha ini? Positive 12. So since these are your factors, bese uzothi tan theta minus 3, bese uyabuya uthi tan theta minus 4. And then uqedile kanjani. So as I check in, ayivoneni, let's say bakunike shisho fana na sin squared theta plus 11 sin theta plus 24. Hey, so la tabuya nyana mara mungachavi mnami. So shisho sungule kulanguta swaku okay na shisha njani. Wabona swaku nina sin to the power 2 na sin wakangana exponent ya power 2. So xilo lexi taka enhlokweni swi lava u cheka swa ku i yi lexi i trigonometric trinomial. Se wa vona leswaku okay ni na sin squared theta and value ya a swi swa ku i 1. Loko nga swi tivi swa ku i te njhani u nga languta video ya hina ya algebra, u nga cheka ti-algebra videos ta hina. So u ta cheka ti-factors ta 24 ane. So ti-factors ta 24 i 1 na 24, 2 and 12, 3, 8, okay, 8, 16, 24, and then 4 na I think 6, yeah, na 6 mtani correct ane. So loko se u ri na ti-factors ta wena xilo lexi xi lavaka i ku u languta ti-factors ta 24, loko u ti hlanganisa swi lava ti ku nyika 11 and loko u ti multiplya swi lava ti ku nyika 24. Se ya vona leswaku 3 na 8 hi toho ti-factors ta hina. Why? Because 3 plus 8 is 11 and 3 times 8 i ta hi nyika 24. So swi swa ku i ta ku sin theta plus 3 and then sin theta plus 8. Done. Se a hi languteni example ya mahetelelo. Let's say now you are given something like cos squared theta minus cos theta minus 6. So now I'm having two negatives here just to make it a little bit nice. So what you do is that, okay, you can notice it's still a trigonometric trinomial. Now you are going to check the factors of negative 6. So minus 6, what are the factors of 6? Okay, 1, 6, 2, and 3, right? So it doesn't matter, guys. Both positives and negatives are factors of negative 6 because they don't leave a remainder. So now you check. There is a negative 1 here as the value of b. The value of b is negative 1. So you are looking for the factors that when you subtract, they should give us a negative 1. And when we multiply, give us a negative 6. So I noticed that if I can take 2 and 3 and make my 3 negative. Why? Because 2 minus 3 is negative 1. Then 2 times negative 3 would be negative 6. So it means that my factors would be 2 and negative 3. So now we'd have cos theta plus 2 because the positive 2, and then you'd have cos theta minus 3, and then close bracket there. So guys, this is where I stop for trigonometric trinomials. So let's check for difference of two squares. Okay, so there's something called a difference of two squares. So if you don't know what's a difference of two squares, please, you can check out our algebra videos on difference of two squares. So the difference of two squares law states that if you have two perfect squares subtracting each other, you can factorize them by having the same or similar brackets or two similar brackets, but with opposite signs. So I won't prove this law. You can just check out our algebra video on that. Okay, so in trigonometry, it would look like what? Let's say now you're given 1 minus cos squared theta, right? So many learners miss that 1 minus cos squared theta. The first thing is that it's an identity of sin squared theta, which is the first part there. And you can notice that 1 minus cos squared theta, it's also a difference of two squares. Why? Because we know that 1 is a perfect square, a perfect cube, or any other perfect thing you can think of. 1 is very special. So what do? You notice 1 is a perfect square, cos squared theta is a perfect square. Therefore, you can have 1 minus cos theta and then 1 plus cos theta. So when you distribute everything here, you'd get 1 minus cos squared theta. So let's check another one. 1 minus sine squared theta. So 1 minus sine squared theta is also an identity of cos squared theta, but don't forget it's also a difference of two squares. How? 1 is a perfect square, so you'd have the square of that, and then you'd have sine theta here and sine theta there, and then you'd have plus and minus. And if you distribute everything, it will give you 1 minus sine squared theta. Okay, so now let's check the ones that are without a 1. Let's say now you're given something like cos squared theta minus sine squared theta. So now if you're given two perfect squares, cos squared theta is a perfect square, sine squared theta is also a perfect square. What do? You write the squares into brackets like that, and then you write another sign there, another sine theta, and then they'll just have opposite signs, and they've been factorized. Thank you for watching our video, but yeah, we'll see you on the next one. Bye bye.